On today's episode of Future Says, we have Mika de Ketelard. She's an adjunct professor at Blair Business School and strategic advisor to IMEC. Mika holds a master's degree in civil and industrial engineering, specialised in robotics and AI. In her recent book, Wanted Human AI Translators, Mika puts the focus on the demystification of the hype around AI. Mika, thanks very much for joining Future Says. Great to have you on the show.
Thank you for having me.
So Mika, a really interesting background. You studied industrial and civil engineering, and now you are a professor at Blair Business School in sustainable, ethical and trustworthy AI. You're a strategic advisor to IMEC as well. How did you make that transition from engineering to now very much a leader within the artificial intelligence world?
Well, that's a good question to start. In fact, if we go back to the beginning, I've always been passionate by technology. So that's why I chose the studies for engineering. Already AI back then, so I'm speaking about 92, 93. Only back then there was no work in that area, so everybody was like jumping on the other bus at that time, which was the internet. So I quickly jumped to the other side and started my career on the internet side, mainly from a business perspective. And it's only over the last 10, 15 years, because the internet, of course, gave us a lot of data. So AI slipped into the world. And it's only like the last years that I realized, well, wait a minute, this AI, has it changed to what I've studied? And then to realize, no, it hadn't changed, but only some of the important things never made the translation. So then I thought, well, this is not correct. So somehow engineers haven't done a very good job in translating correctly to the business how it works. So that's why I said to myself, well, let's then jump back to engineering from the business and let's make sure that we create better, bridges between the two disciplines. And that's what actually happened.
Amazing. And if you put yourself back then in that industrial and civil engineering degree, is there any advice you'd give to yourself or, of course, people in that type of engineering degrees today? Is there any advice you'd give to them when they see all this amazing stuff about AI and they want to get involved?
Oh, absolutely. I think, engineers, they're lovely people. I've got a lot of engineering friends. Being an engineer myself, I'm not obliged to say this, but in fact, engineers have one dream. That's to fix problems with technology, to optimize everything in our world, and to take away some uncertainties that we have. And we get a lot of energy by doing so, but by having so much energy, we sometimes forget that it's not all about just fixing problems with our sometimes narrow mind of engineering. So we sometimes might think that we are God, but God knows He's not an engineer. We should understand that we are not God. So we cannot fix everything just by technology. And so a bit more humbleness and more, deep thoughts through what challenges we should solve with technology and what challenges we shouldn't touch. That's something I would really ask the engineers to look into, because that's not part of our course. So we can't blame engineers. It's not part of our course, and it's still not part after 20, 30 years. It's still not part of our courses at universities. But, seeing the world to a little bit more different lenses than just engineering and technology lenses, that would be fantastic.
Yeah, and we actually spoke a lot in season 2 of Future Says about the soft skills that goes with being a data scientist or a citizen data scientist, and it was often about communication as well. Sometimes you're not communicating your results to somebody that's as technical as you, and you need to be able to say that message in the right way. Would you sort of agree with that?
Oh, absolutely. Yeah. So the AI translator, as I call it, is somebody who finds the right words, making sure that the other side understands it. And this is literally what's missing right now. Technology, it's the easy way out. It's easy to remain in our little corner and do these, funny things with our alphas and betas and formulas. However, we have to understand we need to take a responsibility to translate that work and to say and to explain what the risks are, what the value is, because it's both sides. But I don't think that engineers are doing an extremely good job there. Once we've solved something with technology, instead of explaining it, we are actually getting more energy from solving the next problem. And that's something that we need to turn around. Otherwise, the gap will only get bigger and bigger. So.
Yeah, of course. And we'll talk about all of those very important challenges and things we need to be aware of as we start this transformation. But at the start of the episode, what I want to ask you, you spent many years at some of the biggest tech companies. You've been at SAS, you've been at SAP, IBM, Microsoft. if anybody has seen the value and potential that AI can bring, it's yourself, Mika. So can you cast your eyes back all of those years and give us maybe 2 projects or 1 project which comes to mind where you said that was success, that was return on investment, that was all thanks to AI? Some of those big projects.
Yeah, sure. The good thing is the audience is quite technical here. So we need to know that AI is solving 4 different types of tasks. It's dull, dangerous, difficult, and dirty. My preference goes to the difficult tasks. The difficult tasks are those tasks where there's a lot of data available, but with our human brain, we don't see anything in there. We don't see correlations. We definitely don't see causalities in there, and we sort of get lost in that data. Well, these are the projects where I think AI has shown a very big value. Let me give you one example from the time I was at SAS. Fraud detection. Seeing that how people, just in the clusters of fraudulent people actually move away, start up new companies and do the fraudulent activities again. It's something we don't see. But AI can help us there to augment our intelligent way of looking at the data and make the unseen things visible. So that's one of the things, one of the parts. The other area I absolutely like is where the human body gets to its limitations. We can't look in the dark, we're in the need of light in order to see something. Well, using technology, smart sensors combined with AI algorithms to see in the darkness, that's something I absolutely like, because it's also here again augmenting human intelligence. So these are the 2 areas where I absolutely am very fond of the value of AI. It's, where our body is limiting ourselves from seeing things, in which context we can also arrive in dangerous environments. And then also the domain where AI is helping us on big data challenges to see insights that we can't see. So these are my preferences.
Yeah, so that's great. 2 really good broad areas there where AI can add a lot of value. So if you dug a little deeper then and said the projects within those 2 areas you've worked on, what are the key ingredients to make those projects a success? If you had to give 3 key ingredients to make AI successful, is it business value? Yeah.
Yeah, well, so the first thing is you don't start from the fact of having data. So the amount of times I get people calling me, you're going to be happy because we found some data. I'm like, well, this isn't the right approach. What is the challenge you're going to solve? And then if you get the challenge defined, what's the data that fits to that challenge that will help you solving it? So that's one thing. The second thing is, the second part is that you understand the limitations of data science. It sounds weird, but too many times data scientists, they don't understand that once you operationalize your environment, the world will change, the context will change. And so that means if in a changing context, we already know as a data scientist that your algorithm or your model that you've created, that should be adapted, should be taken out, should be retrained, and should be put back in. Simple facts like these, if you haven't made this part of your project, as follow up once you've put your system out there, that is another reason why AI projects fail. So if you ask me which AI projects went well, that's the part where they thought about this beforehand. So they thought about the operationalization of their environment before moving on to the next project. Something that's all too often missed because it's not needed in rule-based systems. It's only needed in AI systems to have that extra step.
Yeah, absolutely. And so, and I really love that, and I see that business value, that is always the first step. What is the project that we want to do, and how can data help us get there? It's a business use case, not an AI use case, let's say. So in my role, Mika, I go into a lot of engineering companies, and some are very advanced and very mature with technology and have hundreds of thousands of data scientists. Others don't. They have hundreds of thousands of domain experts who are incredibly technical, like you said yourself, coming from backgrounds like engineering, but they don't necessarily have a background in data science, know how to build models. How would you advise these people to upskill a little bit, and how do you get them involved in the conversation?
Yeah, it's a very good question, because indeed what I've seen is that those teams or those companies that succeed in getting the value out of AI are those that actually do a top-down approach and a bottom-up approach. And let me explain myself. The bottom-up approach is indeed having some small use cases that quickly show results, because people are waiting for that. These are use cases which for which the data is, for example, available, where the data is the quality of the data is good, etc. So this just helps them to explain to their colleagues around them, not being the data scientist, what the value could become for the company. However, this just by itself isn't enough. You also need to have a top-down approach. A top-down approach meaning that you have to have your C-level included. And do they need to become data scientists? No. They just need to know to a certain level how that works. The simple example I was giving, that you're going to create a system that's very specific to a certain context, and if the context changes, you need to adapt your system. These things need to be translated to business people. These need to be translated to CEOs, etc. Because if you need additional budget for a system to retrain it, well, they need to be aware of this. And so this top-down approach, demystifying how AI projects run and what type of profiles you need in your team, and then including some bottom-up use cases, is, in my opinion, the best way to look forward and to make sure that AI brings the value it should bring.
And that brings me on to the brilliant book you wrote a couple of years ago, Mika, which is titled Wanted Human AI Translators. Can you tell the audience a little bit more about that book?
Yeah, absolutely. So as I mentioned at the start of this conversation, I noticed that some basic facts didn't make the translation to the business world. Not to the business world, but also to, for example, to public companies. Even with the government, to be very honest. And so I was already doing some of the translation work, just by myself in my projects, making sure that everybody understood what we were doing. And then I was in a debate one day with the Prime Minister of Belgium, and somebody in the audience asked, yeah, but if AI goes wrong, who's responsible? And so he took the microphone and he said, well, it's the engineer. I'm like, oh, wait a minute. No, it's not the engineer. And so I noticed, not only from that conversation or that answer, but also other answers, that in fact it's dangerous if people don't understand how it really works. And that's where I decided to write the book, in order to make sure that, what I was doing on a project by project basis, that I could do it with a much bigger, larger audience. And this is actually what happened.
Yeah, exactly. And it's really important. So this AI topic is universal now. We're not just speaking about data scientists or people that work in this field. Data is obviously affecting everybody. When they look at Netflix, when they listen to Spotify, they're encountering AI algorithms just there. So, Mika, a question for you is, what is an adequate knowledge of data science? What is an efficient knowledge of data science today for people that aren't in those fields? For the shopkeeper beside me in London, to a doctor, to a lawyer, what do they need to know?
Well, of course, it depends on what their role is. Are they just an end user, or are they, like, for example, CEO of a company that's going to apply AI in their daily business? It's a difference, right? But to me, if you compare it to the microwave, we all use microwave in a correct way. Do we understand the physics? No, even not myself, to be very honest. But I know which materials I can use in a microwave, which I can't. To a certain level, if we are going to be users of this technology, which we all are with Netflix, etc., or if we are going to be the company who is going to invest into AI solutions in order to, for example, increase our revenue or decrease our cost, well, to a certain level, we have to also get ourselves informed on, the limitations, the risks, the things that we need to do by design, and the user experience by design, the cybersecurity by design of our systems, etc. So they depend. So if you're a user, to a certain level, we need to know, what's actually happening behind the scenes with our data and with the influences that we are getting through the algorithms. If we are going to be, the company person, the businessman, wanting to, find quick wins like so many other companies have shown us, like the Facebooks, etc. Well, I think we need to dive a little bit deeper and understand that it's really a multidisciplinary debate within our company that we need to have. So that's what I would just suggest.
Yeah. And so we've spoken a little bit about your book. What I want to speak about as well is your role at Vlerick Business School. When we speak to engineering companies, I mean, one of the quick wins that you say, or one of the strategic objectives, is to become more sustainable, both to be more ethical, but also because it is a competitive advantage for these companies. And what you're lecturing on is sustainable and trustworthy AI. Can you speak a bit more about that and what that curriculum entails?
No, absolutely. So, in fact, normally in business, you talk about profit, profit, profit. Let's just be honest and clear. If you don't have consumers, if you don't have products and you don't sell, there's no company. However, that's the old economical model. So the new economical model looks also at the impact of your business onto the planet. I think sustainable has never been as hot as it is today. And also the ethical impact, the impact you're having on people with your technology. And so those 2 points, as we are working with hidden algorithms, because to be very transparent, AI isn't always visible. It is important to make sure that we balance our solutions and our products that we are selling. We balance them out in the new economical model, being mapped between planet and people. So profit, people, planet. And so what I'm doing is I'm showing, first of all, in the planet side, is that AI is doing a fantastic job to a certain cost. Leaving the lights on in the room is better for the planet than turning them off with a voice control during over 1 hour. So just leaving them on for 1 hour, is better for the planet than just turning them off with a voice control. Because why? Because this voice control is always on, always listening, always on standby. There's an algorithm, etc. And some people don't realize it because it's not visible. So showing not only that it has a cost for the planet, having all this technology running powered by AI, but that there's also solutions already available. And because just pointing out the problem is one thing, but showing that there's actually solutions. You can change your environment, where your cloud is based. You can change your heart rate that you're using. You can tune your algorithms. So they're doing exactly the same with the same accuracy, but with lower energy cost. So all these things haven't been made visible also to I would say to businesses. They just remain in research labs, but also there's a work to do. So that's on the side of the planet. So what can you do as a company to make sure you can use a profit, but at a lower energy cost? Second thing is the impact on people. Impact on people is more the ethical side. If you're going to make decisions on the fact that somebody is going to get, right to education, right to a certain job improvement, etc. Well, you have to understand that these algorithms are based on data and on human decisioning from the past. This human decisioning contains bias. So what do you need to do as a company in order to make sure, if you're going to automate this decision, that as much bias is going to be removed from your system, so you don't make the mistakes from the past. So basically my point is not only highlighting these issues on people and profits, people and planet, but also showing that there are solutions available, only they haven't always made it yet to the business world. And that's what I'm educating the students. So how can you measure the problem? What are the frameworks to solve it? What are some good practices? How do you prepare your company? How do you set this up, etc.? What are the benchmarks, for example, in energy efficiency? When do you know that your system is really consuming too much energy, etc.? That's what I'm teaching them through a couple of use cases, and making themselves think about difficult things like fairness. What is fair? What's fair to you is not fair to me, etc. So active courses, very interesting.
And lots of questions off the back of that. Mika, these episodes, unfortunately, they're so short. I mean, we generally try to keep things to 30 minutes, and there's always a limitation on how long the conversation can be. But for people that are really fascinated by what you've said there, and obviously want to upskill in their own time, do you have other resources, books that you like, or papers that you've liked, or videos that you've liked, where they can read or listen to and try to learn a bit more?
Yeah, absolutely. So on the ethical side, there's a lot of recent AI ethical books that have arrived. Mark Kuckelberg is one of them. So they're available in different languages as well. So maybe there's a way to share the titles within your podcast. However, on the energy efficiency side, so on the impact on planet, there's hardly any books. For this, you really need to look more into Google. It's also not a quick fix problem because it's not one size fits all. It depends on what type of solution you have, where it's running, where you base yourself, etc. So, but there's little. I find myself that there's little available books on this. However, there are some good blogs and some good texts available. So this is still to come.
Yeah. Maybe another book coming out soon then, Mika?
Oh, I would love to. I would love
to. Great. Well, on the energy optimization, that's also something you've worked on with IMEC, right? And for people that don't know on the line, IMEC is an amazing research and development fab lab plant in Belgium, doing amazing things within the semiconductor world. So can you speak about how you've tackled that problem with the IMEC standpoint?
Yeah, sure. Indeed. So IMEC is a research center on nanotechnologies and digital technologies. And so basically we can allow ourselves to jump forwards 10, 15 years and in fact work on things that should be improved in order to make sure that technology lands correctly in our society. So if we've divided our AI work in our plan on 3 topics. So energy efficiency is one of them, proving the functionality is the second of them, and then the ethical was the third one. On the energy efficiency, you need to know that we are in an excellent position because we both have the chip development and we both have the algorithms. And if you want to work on energy efficient AI, it's not either the algorithms or the chips. It's in fact a co-optimization between the two of it. And it's finding out the balance depending on the use case that you have. Are you going to be on space tech? Developing solutions for satellites. Well, you have to understand what the, energy availability is there. You need to understand the limitations on connectivity, latency, etc. Or you're working on, for example, a big data environment for health. While you are in a cloud infrastructure, you can look at it in a different way. So there will be different hardware challenges and different software challenges. So by the fact that we have both the digital disciplines and the nanotech disciplines, we can work on these co-optimizations and find answers to the different challenges. So it's really co-optimization between hardware and software. And for this, IMEC is uniquely placed.
Amazing. And in that space, I mean, you sort of said, this isn't necessarily a quick win. This is something that is necessary and something we need to work towards from yesterday, essentially. If you were to, at IMEC, obviously, you need to show success on a continuous basis. So do you have advice on what are the quick wins in that world to try to set your sights on?
Well, I think IMEC, first of all, is European. People sometimes tend to say Europe is squeezed between China and US. And China and US, to be very honest, they're looking at this problem of energy efficiency only lately, in the last year or so, that pops up also on research conferences. They've always played the game of bigger, biggest because they had the hardware available, the big cloud environments, etc., because that's where the trigger mainly plays. Now, when we chose that topic, it was not, but also, from a fact that we wanted to differentiate ourselves with unique research that would put us back on the map. So we went to research not only in cloud, but also on the extreme edge, where you have no energy available. So you have to make these choices on both optimization of the algorithm and the software. And so I think that's where it comes in. But now you see the same research being applied to cloud infrastructures. So where you're also going to juggle with, techniques such as pruning techniques, adaptive learning techniques. My point is that the US and North China had to think about it because the energy was available. So why thinking about it? It was all about accuracy. And investors, if they invested in a company, they wanted to have the company with best accuracy. But, having a critical mindset and saying, well, we can keep the best accuracy, but with a lower energy efficiency level, that never came up. And I think we were triggered to do this, to differentiate ourselves. But now it plays in our advantage, having this knowledge.
Amazing. And you mentioned that IMEC, you came on board and there's now, you're always looking 10 to 15 years in the future. The title of the series, of course, is Future Says, and we always look at what's coming next and how can we best equip ourselves. What else is coming around the corner in those 10 to 15 years?
Well, first of all, the energy efficiency work of IMEC has always been in the heart. It wasn't with my arrival, and just to be clear about my colleagues, it did fantastic work before my arrival. So the other point that's very important is that AI, the functionality remains too narrow. So many AI projects in business fail because the functionality is too narrow. It doesn't comprehend the complexity of certain business processes. And so broadening up the complexity of what AI solutions can do is a very important topic as well. Let me just explain myself. We work, for example, on new sensor fusion techniques. If you look at algorithms right now, they are based on one sensor. And then you have sensor A that does the analysis and sensor B. And then both sensors come together saying, well, I've seen this and I've seen this. That doesn't work. Sometimes you need to just see the complete environment and have fusion techniques that go straight to the raw data before having an analysis individually by sensor. So these are techniques that we are doing, sensor fusion techniques, or distributed intelligence, where one of the sensors can't know it all, and you just put a distributed algorithm on top of all the sensor environment. So all these things will help us to create environments and processes, decisions that can be automated, but which fit much more our complex world instead of having these narrow solutions that we have right now.
Amazing. And so much potential and so many exciting things. You mentioned earlier about having to have both a top-down and a bottom-up approach. So if we try to open up the bottom-up approach a little bit, you've got engineers, they're listening to you, they're super excited, they want to do more. How do you advise them to get their senior management excited, to get their senior management, of course, invest in the ideas that they have?
Yeah, well, in fact, engineers, because that's something that I probably should have mentioned in the previous question, engineers, they will solve it through data. And you can only do so much to a data-driven environment. In companies, there's a lot of knowledge available that didn't get translated yet. You can't just translate it into data. So in the companies, there's a lot of business people around with knowledge about business processes that, in fact, doesn't translate automatically into data environments. And in our opinion, at IMEC, we work at an approach, it's called hybrid AI, where we have knowledge-driven systems digitalized and combine it with a data-driven system. So, for example, with data coming from different sensors. And it's a combination of the two that will actually bring the intelligence forward. It's not the data-driven decision. It's not just the knowledge-driven decisions, but it's the combination of the two. Because what are the limitations? If you look at a data-driven system, it's very easy. You put a couple of sensors, the data is there. However, it will always spit out an answer. However, it's not very transparent. The answer. So business people can't always do something with it. The other way is knowledge-driven systems. Knowledge-driven systems are very transparent. However, if the rule hasn't been created or if the knowledge wasn't available, there's no answer coming out. And we've seen that, by combining both systems, knowledge-driven systems, for example, through knowledge graphs, it's a technology that we use, combine it with a data-driven system, that these combinations actually bring companies much, much, much better forward. We see this now in the chemistry environment, we see this in the pharmaceutical environment, etc. And so to your question, data scientists need to understand their limitations with their data-driven systems. And by collaborating with people who have business knowledge, and by explaining them that this business knowledge should just remain in their stomach or in their head, but can also be digitalized during using new techniques, that this is a smart combination and the way forwards.
I love it. And I encounter this all the time. Data scientists, business people, trying to get them to speak. Because the potential of that hybrid intelligence and that convergence between these two worlds is the future. So Mika, with that potential, how do we do it? How do you get these people speaking to each other? I know you mentioned the technology, but from a more of a collaborative process perspective, how do you get that going?
Well, I think that many people have tried to have a direct line, but I see that it remains difficult. So this is why I sort of call the AI translator as a new type of role that comes in. He or she knows enough about technology, but is maybe not the deep dive data scientist, but has the social skills, the empathetic skills to have people talk to each other and to understand when things aren't clear to one or the other one. Because now you see that business people, as soon as they hear technology, they start looking at their mobile phone and start doing their SMS and their WhatsApp messages. when people from technology hear business, they can't do anything with it. I'm just generalizing it here. But in fact, having a neutral person in the middle who knows as much about business and business value, etc., as much as from technology, without being an expert in the 2 points, well, this person can then help making sure that the bridges are created. And if this person then can just, for example, report to the C-level, then you have best in place, because you have the top-down approach, the bottom-up approach, and you have people collaborating and talking. And so this is the profile that I sort of bring forward in my book. And to be transparent, there's also a course now being created in Belgium about the AI translator. You see the first job descriptions, because people understand that, in fact, that these rules aren't there. And that is because they weren't created at university. And it needs normally a couple of years experience in business in order to get to that level.
Yeah, and I think Gartner actually listed that as one of the next generation job titles within data science, this translator. So if you look to businesses, Mika, who should a business be picking for that type of translator? What background should they generally have?
I'm going to be very direct here. In fact, for me, the social skills here are the most important ones. Ideally, they have a technical background, because AI is a domain that evolves very, very, very quickly, and gets much nerdy, to be very honest. It gets much more into deep dive expertise that's needed. But for me, the social skills are much more important than anything else, because you can see if another person hasn't understood it. You can actually listen to the fact that, they didn't look certain things through, or if there's tension on the line. So this is much more important to me than, being a deep dive expert in NLP or image recognition, for example. I compare it, if I can just allow myself, it's like the generalist, the doctor generalist. Now, before you go to the specialist, you talk to the generalist, and he will listen and understand enough and say, well, I'm sorry, I can't solve this problem, but I think you need to go and see this person. So this is like the doctor generalist, only medical world has had 3,000 years to get to this level. We've only got 70 years to be in a situation right now where people don't understand each other anymore. And so that's my point in my book.
Yeah. I love it, because we've already achieved so much. And some people sometimes say we haven't. It's what has AI delivered? It's delivered so much, and there's so much research going into this, Mika, to go to that next step and to deliver even more. And it's incredibly exciting with these process changes. So, Mika, as a final question, as we start to wrap up, and we sort of spoke about the future already, but what gets you super excited? What gets you up in the morning when you think AI, the potential, where we can go next? What is that one thing that you're super excited about?
I love discussion. But in fact, I'm still very much a fan of AI. I get thrilled. When I see new devices, or when I see new applications. But what gets me up is making sure that people continue to embrace the technology, however, with a more balanced way. So there's, for me, too much fuzz and too much noise in the air around AI. And so you have the believers and non-believers. And I'm like, well, it's a technology. You don't believe or non-believe that it should work. And so what gets me up is making sure people continue to believe in it, so we don't go back into an AI winter, but do it within the new model, taking care of the planet and taking care of people.
Amazing. A brilliant way to conclude. Mika, thank you so much. I will add all of the links to the curriculum at Vlerick, to the different things that you're building there in Belgium. It's super exciting. To the book, of course. Thanks so much for joining, and we'll speak very soon.
Thank you very much for having me. It was my pleasure.
Thanks for watching. Now, next up on altair.com/future says will be François de Heeger, Senior AI Fellow at Michelin. Hope to see you there.